in the chemical properties category. Let us compare the reactivity. See, NH2 on the benzene ring is electron donating group. This is plus M group, electron donating group. All electron donating groups are ring activating and ortho para directing groups. So you can write NH2 on the benzene ring. NH2 on the benzene ring is a ring activating group, ring activating and ortho para directing group. What is the meaning of ring activation? Let us see. Very, very important statement. NH2 on the benzene ring is a ring activating group and ortho para directing group. What is the meaning of this sentence? Let us see. And let us compare the aniline reactivity with benzene also. Let us take one electrophile. Benzene itself acts as a nucleophile. Benzene is considered as a nucleophile. Let us take one electrophile. Electrophile attacks nucleophile, and this is called aromatic electrophilic substitution reaction. Okay, this is aromatic electrophilic substitution reaction. Here hydrogen is there, no? Hydrogen. That hydrogen will comes out as H+. One electrophile is replaced by another electrophile. This is called aromatic electrophilic substitution reaction, right? Clear? H+ leaves and E+ will come. H+ is electrophile, E+ is electrophile. This is electrophile. So electrophilic substitution. Now why I wrote benzene here? Our topic is aniline. Now let us write aniline. Let us consider rate of this reaction. Rate of this reaction is R1. Take aniline. This lone pair participate in resonance. At that time, this pi bond will shift to the adjacent carbon. Okay, pi bond will accumulate as negative charge. Let us write that resonating structure. Nitrogen double bond. Why? Because this lone pair is converting into bond. You know, one lone pair can be considered as a one bond. Imagine this lone pair as a bond and put in between carbon and nitrogen. Resonance. Okay, we are using resonance concept. Clear? This is negative, right? This is first year topic. You know resonance very well. How to shift the bonds? We are using that concept, application of resonance, right? Again, teaching briefly is not possible, right? If you want bond shifting, so go through the resonance in the GOC topic. Again, another resonating structure, right? Here you will get negative double bond. Now observe where negative charge is accumulating. In ortho position and in para position. Ortho and para position. When NH2 is present on the benzene ring, see, if you get any confusion with this bond shiftings, nothing will happen. But remember one point. I'll give you that point. See, you no need to learn this bond shiftings. Just you remember this. That is enough. When NH2 is present on the ring, benzene ring, negative charge will accumulate at ortho and para positions. Remember this point. Not only NH2, any plus M group, any electron donating group. When electron donating group is present, negative charge will be accumulated on the ortho and para positions. Now let us attach electrophile or add electrophile. Now electrophile will attack on the ring, but see, electrophile needs negative charge. Electrophile means deficient, electron deficient. It requires negative charge, electrons. Negative charge means electron. Electrophile is electron deficient, so it needs electrons. You tell me, on this ring where electron density is more, at ortho and para. So preferentially electrophile goes towards ortho or para positions. That's why NHT is called as ortho para directing group. It directs, NH2 directs incoming electrophile towards ortho or towards para. Ortho para directing group, NH2 on the benzene ring. Clear? Now we wrote R1 here, and I am taking one product E. Another para also will come, but write only one R2. Once observe these two boxes. In this box, benzene is involving in aromatic electrophilic substitution. Here aniline is involving in aromatic electrophilic substitution reaction. Guess which is more reactive towards electrophile, plain benzene ring or aniline? Which one? Online students, plain benzene ring or aniline? Why aniline? Why aniline? Because in aniline NH2 is a plus M group, electron donating group. Aniline NH2, in aniline NH2 increase electron density on the ring. It supply electrons to the ring, so electron density over ring increases, so electrophile will come easily. Attack of electrophile is very easy. So aniline is more reactive than benzene towards aromatic electrophilic substitution. This is final conclusion. Aniline is more reactive towards aromatic electrophilic substitution than benzene. Reactivity comparison. And NH2 group is which group? Activating group. Ring activating. What is the meaning of ring activation? See, ring activation means increasing negative charge on the ring and making attack of electrophile very easy. If more negative is present on the ring, electrophile will come easily. That is called as activation. By releasing electrons into the ring, it increases the reactivity. That is called activation, ring activating group. Right? All plus M groups are ring activating as well as ortho para directing groups. This is reactivity comparison of aniline with benzene. Okay. So relation R2 greater than R1, R2 greater than R1. Here we will get another product also. Which product that is? Para. Para will be the major one. Para is major due to less repulsions. In the para, repulsions are less. Generally para product will be major product. Clear? Bromination. First property, electrophilic substitution. Bromination. Aniline when treated with bromine water. Bromine in the presence of water, addition of bromine. Bromine CS2, carbon disulfide, or you can use chloroform also, CHCl3. I think you listened already in your college. Anybody, can you guess what may be the product here? Two, 4, 6 tribromo aniline. 2, 4, 6 tribromo aniline. 2, 4, 6 tribromo aniline. With bromine CS, with bromine carbon disulfide, ortho and para. What is the reason why? Why? See, when we take water, polar solvent, polar protic solvent, it enhances the ionization of bromine molecule. Bromine Br2 is molecule. It converted to ions. It increases the ionization of bromine molecule. So more number of bromine ions will come out. Okay, bromine plus and bromine minus. So more number of bromines will attach. Very simple reason. Water is a polar compound, polar protic compound particularly. It enhances the ionization of bromine molecule. Bromine molecule dissociates into ions. Right? More number of ions will come and more number of ions will attach. That's why we get a tribromo, polybromination. This is called as polybromination. Number of bromines 3. Monobromination only, orthobromo and parabromo aniline. CS2 is a non-polar compound. Okay, ionization is very less. Less number of ions will generate and less number of ions attached to the ring. Simple reason. CS2 is a non-polar solvent, non-polar compound. Ionization of bromine molecule is less. Extent of ionization is less. Less number of ions will generate and less number of ions attached to the ring. Okay. Next, nitration. Nitration of aniline. Nitration of aniline. Nitration of aniline. What is nitration mixture? What is nitration mixture? Sorry, come again. Concentrated HNO3 plus H2SO4. This is a nitration mixture. Concentrated HNO3 plus H2SO4. What is its role? It introduces NO2 group. Guess the product, major product. What will be the major product here? See, in organic chemistry, memory-based questions probability is very less. But for this question, percentage is very, very important. 51%, 47%. What is remaining? 2%. Percentage is very, very, very important. Percentages. Okay. 51, 47 and 2%. But the question is, what is NH2? Which directing group? Ortho-para directing group. Clear? But why we are getting meta product? That too with more percentage. This percentage is very important. By heart the percentages. Okay? Clear? What is its nature? Plus M group. NH2 is a plus M group. To do nitration, we have to use the nitration mixture. In nitration mixture, what is present? In nitration mixture, acid is present. So protonation takes place. Nitrogen contains lone pair. See, immediately protonation takes place. Here, nitrogen donates its pair of electrons to H+, which come from the acid. Then we will get NH3 positive. Plus M group will convert it to minus M group or minus L group. Very, very important. In acidic medium, in the presence of acidic medium, plus M group will convert it to minus M group. Clear? So with NH2 what we will get? We will get ortho and para. With minus M group what we will get? Meta compound formation takes place. That is the reason. Clear? Why we are getting meta product? Generally when plus M groups are present, we will get ortho and para only. But in the case of aniline, particularly we are getting meta. the more percentage. What is the reason for that? Acid is present in the reaction mixture that attacks NH2 and converts NH2 to NH3 positive. Plus M group will convert it to minus M. So we will get a mixture of products, ortho, para and meta. Got it now? Online students. Clear? Okay. Srujan, now it is okay? So plus M, the electron donating group in the presence of acid will convert it to electron withdrawing group. And you know electron withdrawing groups are meta directing groups. That's why we are getting meta product also. Meta product also. Clear? Right. Percentages are very, very important. You should by heart that percentages, everyone. Anilinium ion, yes. Like ammonium ion, anilinium ion. Okay? Right. Other students, did you get this? All of you. Aisha. Mazia. Do you have any doubts in this? Plain NH2 is a plus M, ortho para directing group. That's why we got where it is ortho and para, because of NH2. But when we use this reagent, clear, this plus M group is converting into minus M, and minus M groups are meta directing. That's why you are getting meta product also. Clear? Percentages are very, very important. In the presence of reagent, what you are using for the nitration, this donating group is converting into withdrawing group, and withdrawing groups are meta directing. So you are getting some meta product also. Clear? Very, very important point. Clear? Next, keep reading. Friedel-Crafts alkylation. Friedel-Crafts alkylation. No one is responding. His syllabus is over in your college, Adiba? Over or not over? Completed? Am I audible to you? Okay, see. Next, Friedel-Crafts alkylation. Tell me what is the product here? Aniline. What is alkylation definition? Introduction of alkyl group. Introduction of alkyl group is called as alkylation. Correct? So which product we will get? Means methyl. See, this is Friedel-Crafts reagent. Friedel-Crafts, very, very important. Sorry. Yes. Someone said. Yes. Very good. Reaction do not take place. Aniline do not participate in Friedel-Crafts alkylation. Very, very, very important. Aniline do not undergoes Friedel-Crafts alkylation. Why? What is the reason for that? Let us see. You can write aniline do not undergo Friedel-Crafts alkylation. See, what is Friedel-Crafts alkylation? Friedel-Crafts alkylation is an example of aromatic electrophilic substitution. Aromatic electrophilic substitution. First year topic. This is first year benzene chemical property. Friedel-Crafts alkylation. Once again, I will revise. What is the mechanism of Friedel-Crafts alkylation? I will take one example. You remember this temporarily. Aniline do not undergo Friedel-Crafts alkylation. Let us see the reason after completing revision of Friedel-Crafts reaction. So this is Friedel-Crafts reaction. Friedel-Crafts alkylation. Alkylation means introduction of alkyl group. CH3Cl AlCl3 gives rise to CH3. This is Friedel-Crafts alkylation. See, mechanism is important. Look at this. CH3Cl. Aluminum is surrounded by how many chlorines? 3 chlorines, right? Each bond contains how many electrons? Each bond contains how many electrons? Each bond contains 2 electrons. Total how many electrons are present in the circle? 6. Means octet is? Octet is not present. Octet is not present. So this chlorine present here with methyl group. This chlorine leaves along with the bonded electrons. See how arrow is writing here. Along with the bonded electrons means this electron and this electron. Chlorine takes its own electron and electron of a carbon also as a Cl negative. It is taking one extra electron and attaching to AlCl3. Why? Due to deficiency at the aluminium. That is the driving force. Aluminum is attracting chlorine because aluminum is deficient, right? Aluminum is having only 6 electrons. It requires more 2 electrons to complete octet. Okay, that's why aluminum is going along with the chlorine is going along with the bond pair of electrons. Then what about carbon? Carbon will get a positive charge. This step is important. Electrophile generation. What is the role of AlCl3? AlCl3 is used to generate electrophile. So byproduct is AlCl4. You no need to go other about that. Just write AlCl4 negative. Electrophile is generated or not? Electrophile is generated. CH3 plus is generated. This is step 1, generation of electrophile. Step 2 is after generation of electrophile, this benzene will be attacked by that electrophile. This is the reaction of Friedel-Crafts reaction and useful in every chapter. Remember Friedel-Crafts alkylation mechanism. Okay. And the step 1 electrophile generation takes place and the step 2 attack of electrophile will take place. But this is the mechanism. Right. Perfect. Yes. Correct. So benzene is participating in Friedel-Crafts alkylation. We are getting product also, methyl benzene. If we take aniline, what happens? See, for the Friedel-Crafts alkylation, the key step is generation of electrophile. First electrophile should be generated. Clear? Then only that electrophile attacks on the ring. This reaction should take place. This step should take place first in the Friedel-Crafts alkylation. Clear? But when we take aniline, this step do not take place. Electrophile will not be generated. Attack will not take place. Why electrophile generation do not take place when we take aniline? Clear? This is electrophile generation. This step do not take place. Let us see why. What is happening? How electrophile is generating? You tell me how electrophile is generating. When chlorine leaves along with bond pairs and attaches to AlCl3, then electrophile is generating. CH3 is converting into CH3 plus. Clear? Right. But when we use aniline, see aniline is having lone pair or not? When we use aniline, before attack of this Cl with the bond pair of electrons, before attack of Cl, AlCl3, aniline lone pair attacks AlCl3. Aniline is having lone pair or not? AlCl3 requires 2 more electrons to complete octet. It is ready to take electron from others. If NH2 gives electron fastly, AlCl3 accepts electron from NH2 only. If CH3Cl gives electrons fastly, then it accepts electron from CH3Cl only. But you tell me, this is bond pair or not? This is bond pair. Cutting this bond pair is difficult, but here free lone pairs are present. Free lone pair of electrons are present. So they attach to the AlCl3 easily. Clear? Now how electrophile will generate in this case? CH3 positive will not be generated. Clear? That is the reason. So what happens when we use aniline in the Friedel-Crafts alkylation? Nitrogen lone pair attacks AlCl3 and electrophile generation is inhibited, stopped. That's why reaction do not take place. That is the reason. What is the use of this total expression? Nothing. Remember statement. Aniline do not participate in Friedel-Crafts alkylation. Okay, right. Shall I clear this? Shall I clear this, all of you? Bhakti, do you have physics class now, today? Oh, super. Reaction with the okay. Then I'll continue. Okay. Reaction with the acid halides. RC double bond OC in the presence of pyridine solvent. First acetylation. Introduction of acetyl group is called as acetylation. Introduction of acetyl group. What is acetyl group? CH3 C double bond O. This is acetyl group. Acetyl are also called as acyl. Acetylation or acylation, both are same. Acetylation or acylation. Acetyl or acyl group. CH3 C double bond O. Acetylation or acylation. Aniline NH2. Can we write like this? NHH. Acetyl chloride. In the presence of pyridine solvent. See. Remove chlorine and hydrogen. Minus HCl. See this. C double bond attaches to nitrogen. NH C double bond to CH3. What is its name? Which functional group is this? Which functional group is it? Amide. CONH2 amide. Acetonylide, commonly also called as acetonylide. Phenyl ethanamide, also called as acetonylide. Other students, respond all of you. Hello. P wise transfer pyridine solvent. Pyridine. Sometimes we will get structure of pyridine also instead of symbol. Both are same, pyridine. Pyridine solvent. Clear? You know one interesting pointer. What happens when we add nitration mixture to aniline? We'll get a 3 types of product. Clear? Right. Without getting meta product. How can we get only paranitro? How can we get only paranitro? That is the task. Clear? We don't want meta. See, this aniline is highly activating group. And the lone pair also available for the proton. So what we have to do? We have to keep this lone pair busy. Actually here H plus will come, right? And attack lone pair. If we keep this lone pair busy in resonance, then H plus do not attacks. Then this NH2 do not converted to NH3 plus, means minus M. Clear? How to convert this lone pair busy? How to keep this lone pair busy? By using this reaction. Very important reaction. First we have to do acetylation of aniline. Look at this. Is actually reaction is over. Reaction with the acetyl chloride, acetylation is over. But I'll tell you the application of acetylation of aniline. Look at this. Is this over? This reaction is over. Is this over? All of you. Not done. I'll tell you application part next. Not done. What happened? Take this as it is. Extension application part only will come, right? This is application part. Concentrated HNO3 plus H2SO4 nitration. Okay. Additionally, I am giving this bromination. Bromine in the presence of AlCl3 or Fe also, even you can use Fe. See, now this lone pair is in resonance, right? Resonance with the carbonyl group. So less available for proton. So conversion of this NH group to minus M is impossible. Clear? So now this acts as only plus M group. So NO2 positive electrophile preferentially attacks para position, because in ortho hindrance crowding is there. So major product will be para. NH C double bond NH2, here NO2. But our final aim to get a NH2 here and NO2 here. But how to get NH2 here? By doing hydrolysis. Or you can do this later. Addition of water, H2O or H3O plus. Add water to this. Addition of water to this amide. Hydrolysis. Don't bother about the byproduct. Clear? And note. Okay. Here actually I have to write this C double bond. No one is saying here. And CH3 there, na here. No one is saying that. What is the byproduct here? What is the byproduct here? Acetic acid is the byproduct. Don't bother about byproduct. Clear? We got aniline with the note. Very, very, very important reaction. Clear? Next. Schatten-Baumann reaction. Schatten-Baumann reaction. Acetylation is our next. Benzoylation. Benzoylation of aniline in the presence of aqueous base is called as Schatten-Baumann reaction. Benzoylation. Benzoylation of aniline. The presence of in the presence of aqueous NaOH, aqueous base is called as Schatten-Baumann reaction. Similar to acetylation only, but here we will change the structure of acid halide. See this. Aniline can be written as NH and H. Okay. Cl C double bond O. Benzoyl chloride. Schatten-Baumann, you can write in the bracket, this is called benzoylation. 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 Introduction of benzoyl. Benzoyl means this group is called as benzoyl group. This is benzoyl. Benzoyl group. In the presence of aqueous base. Mechanism is similar to that of acetylation. Remove hydrogen and chlorine minus HCl. HCl will be eliminated and this unit will attach to N. Okay. NH C double bond O. This is N-phenyl benzamide. N-phenyl benzamide. N-phenyl benzamide. This is called Schatten-Baumann reaction. In phenol also we can see this. Phenol starter. Correct? Already this reaction came once. Are you following everyone? Online students? Benzoyl group. Benzoyl, what is its name? Benzoyl chloride. That is acetyl chloride. This is benzoyl chloride. Benzoyl chloride. Its name benzoyl chloride. Next. Reaction with NaNO2 plus HCl at 0 to 5 degrees centigrade. At 0 to 5 degrees centigrade. This reaction is called as, say its name. What is the name of this reaction? What is the name of this reaction? Diazotization reaction. Diazotization reaction. Preparation of diazonium salt is called as diazotization. Preparation of diazonium salt. Preparation of diazonium salt is called as diazotization reaction. Aniline when treated with NaNO2 plus HCl at temperature conditions are very important. At 0 to 5 degrees centigrade, we will get benzene diazonium chloride. Benzene diazonium chloride.